Good morning, students. Today I explain about some of the important models in optical instruments. The name of the topic is optical instruments. See the first question. One simple question is given here. A person looks at different trees in an open space with the following details. Arrange the trees in decreasing order of their apparent sizes. So here no instrument is used in the first question. Simply the person looks at different trees in an open space only. No microscope is there, no telescope is there, nothing is used. So directly when you observe the trees at different distances for different heights. So really 4 cases were given here. Out of the 4 cases, there are different heights only for all of them. So real heights are different. But when you are at different distances from each one, which will appear to you at more height or at less height, that they're asking the question. So here you have to see only the angle subtended by our eye for each and every tree. For example, somewhere here we have a tree and somewhere here if person is standing, if the person wants to see the image, as you know, this is the angle subtended here. This angle is nothing but arc by radius. What is the arc length in different cases? It is different in different cases. In first case, I will take the general formula here. I will write. Then theta is nothing but height of the tree. Arc in the sense height of the tree by radius in the sense distance only. For all the 4 trees, you can just write here the values. And for the first one, it is 2 by 50. For the second one, it is 2.5 by 80. And of course, all are in meters only. And third one, 1.8 by 70. Fourth one, 2.8 by 100. You have to write them in decreasing order only. Na? Just see here the values 2 by 50 in the sense 0.04, 2.5 by 80. That means 250. It will be 1 by 32. That will be nearly 0.03. And 1.8 by 70. It is 0.025 something, nearly 0.026. And this one directly you can write 0.028. You have to write in decreasing order only, na? Which will have the more angle subtended here. That is for A. A is having more apparent height. And next one after A it is B. And next one it is D. And the last one it is C. In the decreasing order, all the values were written here. Now question number 2. An object is to be seen through a simple microscope of focal length 12 centimeters, where the object should be placed so as to produce maximum angular magnification. The least distance for clear vision is 25 centimeters. And here, what type of instrument was used? Simple microscope. And we know that simple microscope is nothing but a single convex lens. A simple single convex lens. So what is the focal length given for that single convex lens? Focal length is given 12 centimeters. And what else given? Where the object should be placed. That means you have to find out. Object position you have to find out so as to produce maximum angular magnification. When does the angular magnification becomes maximum? There are two possibilities I explained. One is the image may be formed at distance 25 centimeters, or image may be formed at a distance of infinity. Infinite. So in both the cases, whenever image is formed at low distance, less distance, then only the eye has to subtend with more angle. That means angular magnification should be more in only in this particular case. And the least distance for clear vision, that means final image should be formed at 25 centimeters. And of course, every time below the lens, before the lens only. So that is minus 25 centimeters. So when you know the value of F and V, and finally you have to calculate U value. Which formula we use in case of a single lens? Of course, it is simple microscope only. That is 1 by F equal to 1 by V minus 1 by U. So simply you can substitute the values given. This is minus 25 minus 1 by U. And of course, for 1 by U, it will be minus 1 by 25 minus 1 by 12. For 25 and 12, you can just take LCM here. That will be nearly 600. No. 300. So this will be 25 minus 12 minus 25. This will be totally minus 37 by 300. That is the value of 1 by U only. And finally, U will be minus 300 by 37. 300 by 37, that will be minus 37. 10 jar 370 only. Only it will be 37. 8 jar. 240, 296. 440, that means nearly minus 8.1 centimeters. And the answer for you will be minus 8.1 centimeters. This is very simple question. Then question number 3. A simple microscope has a magnifying power of 3 when the image is formed at the near point of a normal eye. Here also simple microscope was taken. Magnifying power M is given 3 when it is equal to 3 when image is formed at near point. What is the formula for magnification? When image is formed at near point in case of simple microscope, that is MD equal to 1 plus. In the classroom only I derived it. This is 1 plus D by F. What is M given? 3. 3 equal to 1 plus 25 by F. And what is the first question? What is its focal length only? Na? From this equation only easily you can solve. Then 25 by F becomes 3 minus 1 will be 2. So F will be 25 by 2, which is equal to 12.5 centimeters. The first question was completed. And what is the second part of this question? What will be its magnifying power if the image is formed at infinity? So that is also a simple formula for magnification when the image is formed at infinity. What is the formula in case of simple microscope? That is simply D by F only, na? And D was already given, which is equal to 25. And F we calculated now, that is equal to 12.5 centimeters. And the ratio becomes 2. And answer for the second part will be 2 only. One more simple question. A child has a near point at 10 centimeters What is really the near point is 25 centimeters for the healthy person only, in average distance only. But here it is given for child, it is 10 centimeters. What is the maximum angular magnification the child can have with a convex lens of focal length 10 centimeters? And already I told you that when do you have the maximum magnification? Maximum angular magnification we have only when the object is at near point. Which is the formula then? It is also simple microscope only, na? Because it is a single convex lens. So the formula will be 1 plus d by f. That is 1 plus d is given 10 centimeters here. Focal length is also given 10 centimeters. Then simply the answer will be 2 only, the maximum angular magnification. One more simple question based on simple microscope only. A simple microscope is rated 5 multiplication for a normal relaxed eye. What will be its magnifying power for a relaxed far-sighted eye whose near point is 40 centimeters? Okay. So see the first case. In general, for the relaxed eye, what is the magnification given here? Magnification is given 5. And for the relaxed eye, what is the formula? This is nothing but 1 plus d by f. Okay. For the first case, simply you can take it is equal to 1 plus, and of course 5 equal to 1 plus 25 by f. So 25 by f will be 5 minus 1, 4 only. Then f will be f will be 25 by 4. And of course, here the near point distance is given 40, na? Sorry, you can write 40 here for 25. This will be 40 by 4. 40 by 4 will be 10 only. So focal length of lens is given 10 only. Okay. Now they're asking the question, what will be its magnifying power for a relaxed, far-sighted eye? That means when the image is formed at infinity. So in that case, what is the formula for magnification in case of simple microscope? That is simply d by f only, na? Okay. What is the d? It is 40. Yep. Just now we calculated that is 10. So the magnification will be 4 only. And question number 6. Find the maximum magnifying power of a compound microscope. So here the information is given about compound microscope having a 25 diopter lens as the objective. So what is the power of objective lens? Power of objective lens is given 25 diopters. But mostly we use the focal length value only to solve many things here. So what is the formula for power? 100 by f only, na? 100 by f equal to write in centimeters, 25. Then f will be equal to 100 by 25, which is equal to 4 centimeters. In the same way, I write for eye lens also. 5 diopter lens as the eyepiece and the separation given something. First I will calculate this. Power of eyepiece is given 5 diopters. In the same way, if I solve here 100 by f equal to 25, 100 by f equal to 5, then f eyepiece will be 20 centimeters. Of course, in compound microscope, both the lenses are convex lenses only, na? So that both the values are to be taken positive. And The eyepiece and eyepiece, okay, has the eyepiece and separation 30 centimeters between the two lenses. So for example, if I draw a compound microscope, just a rough diagram for a compound microscope. Okay. Somewhere here, let me consider one object is taken. So then this is objective lens, this is eye lens. So this is called as object distance for objective lens. And of course, it will form some image at some point on other side. And this distance is said to be image distance of objective. And here, this is the image from the first lens can act as object for the second lens only. Na? So this can be taken as object distance for eye lens. And wherever the final image is formed, so of course it is given that 25 centimeters. That will be V eyepiece, which is equal to 25 centimeters. Of course, it is minus 25 centimeters you can take because the image will be formed on the left side of the lens only. Na? So that now only focal length values we know here. And the separation was given. Separation means sum of VO plus UE. That sum is given 30 centimeters. This is completely the information given in the question. Now, which one you have to calculate? Find the maximum magnifying power of a compound microscope. Maximum magnifying power for my compound microscope in the sense at nearest point only. Na? This is equal to minus VO by UO into, well, if you know the formula, I hope, 1 plus D by FE. This is the formula we have, that you have to substitute all the values there and you have to find out. But directly we don't have the values of VO, UO, all these values we don't have. But now you have to calculate. First of all, for objective lens only, I will use the general equation. For objective lens, which formula I can use? And of course, 1 by F equal to, for any lens, I can use 1 by F equal to 1 by V minus 1 by U. And all are for objective lens only. Now, what is the focal length of objective? That is equal to 4 only, na? 4. 1 by 4 equal to. And image distance for the objective lens. Only for objective lens, you have to write the image distance here. But when you go through this, you cannot find out for objective lens because VO we don't know, UO both we don't know. Na? So that first I will go through the calculation for eye lens only. Later on I will solve this. For eye lens, the same formula you can write only. Na? 1 by FE equal to 1 by VE minus 1 by UE. What is the focal length of eyepiece? That is 1 by 20 equal to 1 by image distance is minus 25 only. Na? Image distance is for eye lens is minus 25 centimeters. Minus 1 by UE that we don't know. So then 1 by UE equal to minus 1 by 25 and minus 1 by 20. And the LCM will be 100, 25, 4 jar minus 25 jar, that will be minus 9 by 100. and then UE equal to minus 100 by 9. 100 by 9 will be 11.11 something. And of course, minus 11.11 centimeters is the formula for UE. But finally, you have to calculate MD only. Na? For that, which factors are required? D already you know that. FE was given already. You have to find out the values of VO and UO. Okay. To know those values, first of all, UE is 11.11 centimeters. And here I have written that VO plus UE is 30 centimeters. And already here I got UE value. Then what is the value of VO? VO is nothing but 30 minus UE, which is equal to 30 minus 11.11. This is 18 point, I think 18.89 centimeters. So that we could know the values of VO only. Na? Now we can substitute that. 1 by 18.89 minus 1 by U naught, that we don't know. So 1 by U naught will be 1 by 18.89 minus 1 by 4. LCM will be just the product of these two only. Na? That will be nearly, I will take it 19 only. For 19 jar, that will be 76. And in numerator, you will get minus 14.889. By nearly it is 76, but not exactly. Then this is 14 5s are 17, 14.89 something. So nearly it will be minus 1 by 5 only. You will just get 5 point something, but nearly I will take here minus 1 by 5. It is for 1 by U naught. And U naught will be how much then? This will be minus 5 centimeters. So just now we got the values of U naught and what is the value of V naught? 18.89. By substituting these values here, what is V naught by U naught? Minus V naught value we got 18.89 by this will be minus 5 into 1 plus 25 by focal length of eyepiece is 20. 25 by 20 in the sense 5 by 4. It will be 9 by 4. By calculating all these, you will get the answer nearly 8.4. The nearest answer you will get, that is 8.4. Magnification only, na? There will be no unit for magnification. You should not write in centimeters or something else. Okay? Have you observed it clearly? A compound microscope is given. Focal length values are given. And the separation between both the lenses is given. And the magnification, maximum angular magnification, that is possible at near point only, na? So you have to calculate like this. Now question number 7. The separation between the objective and eyepiece of a compound microscope can be adjusted between 9.8 centimeters to 11.8 centimeters. So the distance is movable there. The lenses are movable there so that the distance can be arranged. And what is the possible arrangement that is in between 9.8 centimeters to 11.8 centimeters? If the focal lengths of objective and eyepiece are given, so just I will write here I think the similar question as the previous question it is. Focal length of objective is 1 centimeter. Focal length of eyepiece is 6 centimeters. And find the range of the magnifying power if the image is always needed at 24 centimeters from the eye. So capital D is nothing but 24 centimeters. And the question here is range of magnifying power. And what is the magnifying power formula? The similar one as in the previous case. What is the magnifying power? Equal to minus VO by UO into 1 plus D by FE. Again, for the two separations, separately you have to calculate the magnifying power. In the first case, as in the previous case only I mentioned, for objective lens, what is the formula we use? 1 by F objective equal to 1 by V objective minus 1 by U objective. For eye lens, 1 by FE equal to 1 by VE minus 1 by UE. Okay. So FE value, we know that already. What is that? 1 by 6 equal to. For eyepiece, where does the image form? At 24 centimeters only, na? So that you can mention here minus 24 minus 1 by UE. By using this, you can calculate the value of UE only, na? You will just get calculate. You can calculate UE value when by substituting in the separation. What is the separation? Image distance of object to plus object distance of eye lens. The sum is given 9.8 centimeters in first case. If you know the UE value, you can know the VO value. Na? By substituting here, you will get UO value. Then you can substitute here and you will get the answer for magnification. Just whatever we have solved in the previous question, the similar method we have to use for 9.8 centimeters separation and separately for 11.8 centimeters separation also. So two answers you will get. Okay, then you can decide the range there. And answer given, you can just try to solve it by your own. If you really understand the previous question, definitely you will be able to solve easily. Okay, so the range of magnifying power is 20 to 30 given. That means for one case, you will get the answer the 20 magnifying power. And for the second case, you will get 30. First case in the sense, for 9.8 centimeters total separation. And the similar derivation, in second case, it is for 11.8 centimeters. Okay, you please try to solve. And I can distinguish between 2 points of an object if they are separated by more than 0.22 millimeters. When the object is placed at 25 centimeters from the eye. See that this is nothing but about resolving limit and resolving power. So to see the two objects separately, what should be the minimum distance directly if you want to see? That is 0.22 millimeters given. Next point. The object is now seen by a compound microscope. Initially, no instrument is used. Directly with our eye, we have seen that. What is the minimum distance to see them separately? 0.22 millimeters. And in the next case, a compound microscope is used. Of course, the focal lengths are given 20 diopter for powers are given 20 diopters for objective and 10 diopters for eyepiece, separated by a distance of 20 centimeters. The final image is formed at 25 centimeters from the eye. Okay. What is the minimum separation between 2 points of the object which can now be distinguished? Now the resolving limit they are asking. Only with I, the resolving limit is given 0.22 millimeters. And by using compound microscope, ఇంకా తక్కువ డిస్టెన్స్ కూడా చూడగలం కదా. Now what is the resolving limit they are asking? To know the resolving limit, first of all, how much magnification we can have by using the microscope, that we should know. So based on the information given, you have to derive an equation for magnification of compound microscope. Then directly you can solve for resolving limit. Okay. Now, how can you calculate the magnification? As in the previous two questions, whatever the method we followed, the same method here also we have to follow, because 20 diopter focal length is given, the power is given, 10 diopter power is given. What is the formula for focal length of objective? It will be 100 by 20. Directly I'm writing here. That is 5 centimeters. And focal length of eye lens. Power is 10 diopter. Focal length will be 100 by 10. That is 10 centimeters. And separation between them. That means V objective plus U eyepiece. That is equal to given 20 centimeters. And final image is formed at 25 centimeters only. Na? That means image due to eyepiece is formed at minus 25 centimeters. In last two problems, whatever the method you have followed, the same method here also you have to follow, and you will get here the magnification. Then you will get the magnification here, that is equal to 5.5. You will get the magnification that is equal to 5.5. Now, initially with I, this is the resolving limit. And now by using this much of magnification, very less distances also you can see only. Na? So that the resolving limit or minimum separation you can see. That is minimum separation you can see by using compound microscope is nothing but 0.22 millimeters by 5.5. How much more magnification you will get, that much minimum separation also you will be able to see. So this gives the answer nearly equal to 0.04 millimeters. Again and again, the same method we have to follow. That's why I skip here. Okay, please you solve that. A question on telescope only. An astronomical telescope is to be designed to have a magnifying power of 50. So what is the value of magnifying power given? M is given 50. What is the general formula of magnifying power in case of astronomical telescope? That is nothing but F objective by F eye lens. That is given 50. That means objective lens focal length is 50 times to the eye lens focal length. That is the information given in the first line. What next? If the length of the tube is 1 or 2 centimeters, if this is the diagram for astronomical telescope, of course the first one's focal length is more than second one. Objective focal length is more than eye lens. So this length is given 1 or 2 centimeters. In case of astronomical telescope, we know that object is at almost at infinite distance. And for normal adjustment given, here you can consider image is also formed at infinite distance. If object is at infinite distance, image will be formed at focal length of objective lens only. Na? If the final image formed at infinite due to eye lens, then this object should be at focal length of eye lens only. Na? So sum of these two is nothing but distance between the lenses. So that is only tube length. So objective lens focal length plus eye lens focal length totally given 1 or 2. Okay. Now, see here, FO equal to 50 FE. Na? Now you write down FO equal to 50 FE plus FE equal to how much? 1 or 2? 50 FE plus 1 FE will be 51 FE equal to 1 or 2. Then FE will be 1 or 2 by 51, which is equal to 2 centimeters. 2 centimeters. And what is the focal length of objective then? For islands, if it is 2, for objective it is 50 into 2, na? So that will be 100 centimeters. But the question is not to calculate focal length values. We have to calculate here power values. So power of objective is nothing but 100 by F if focal length is in centimeters only. Na? Now, what is the focal length of objective? 100. So 100 by 100 equal to 1 diopter. Okay. For power of islands, that is also 100 by FE, which is equal to 100 by, what is FE value? 2. 100 by 2 will be 50 diopters. So answers will be 1 diopter and 50 diopters. The eyepiece of an astronomical telescope. This question is also based on astronomical telescope. Has a focal length of 10 centimeters. First, I will write here about focal length of eyepiece. That is, focal length of eyepiece is 10 centimeters. The telescope is focused for normal vision of distant objects. Ante, astronomical telescope ante to see the astronomical objects which are at long distances only. Na? అంటే అక్కడ ఇమేజ్ ఫామ్ అయ్యేది కూడా ఇన్ఫైనైట్ అని. సో ట్యూబ్ లెంత్ ఇచ్చాడమ్మా. యాజ్ ఇన్ ద ప్రీవియస్ క్వశ్చన్ ఓన్లీ దిస్ ఈస్ focal length of objective plus focal length of islands. Sum is given 1 meter, na? But you better write in centimeters, all of them. So that you can write 100 centimeters. If FE is 10 centimeters, what will be FO value then? 90 centimeters only, na? Okay. With that information, you could calculate objective focal length also. Now the question is, find the focal length of objective and magnifying power of telescope. Focal length of objective, already we got the answer here. And very much simple question it is, magnifying power of telescope. Of course, it is when it is found at infinite only, no? Then what is the formula? In case of this, it is FO by FE. What is FO? 90. FE is 10. Then the ratio will be 9. Very good, very good. 6 members gave the answer. Very good. Answer is 9 only. The Galilean telescope is 27 centimeters long. So Galilean telescope means, already explained in the classroom only. There are 2 lenses in the Galilean telescope. But one lens is convex lens and other lens is concave lens. In normal astronomical telescope and terrestrial telescope, both are convex lenses only, na? So that focal length can be taken positive for both of them. But when it comes to Galilean telescope, focal length of object lens is positive, focal length of eye lens will be negative. So tube length will become FO minus FE. Concave lens kadama. That's what is FO minus FE you can write. Now, what is length given? 27 given, na? 27 centimeters is given for length. And focal length of objective is given 30. So it is 30 minus FE. So FE equal to ఏమొస్తుందమ్మా ఇప్పుడు 30 minus 27. అంతే కదా? Which is equal to 3 centimeters. You can ask a question that, sir, eye lens is concave lens only, na? You should get negative value only, na? But already in the formula only I have taken negative, na? In the formula itself, I have taken negative so that I got the positive value. Okay. But here, answer is minus 3 centimeters actually. But magnitude only you can write, that is 3 centimeters. Next question. A far-sighted person cannot see objects placed closer to 50 centimeters. Find the power of lens needed to see the objects at 20 centimeters. That means he can see the objects at least the distance 50 centimeters. 50 centimeters కంటే ఎక్కువ దూరంలో ఉంటేనే చూడగలడు. అంతకంటే దగ్గరగా ఉంటే చూడలేడు. Then we have to use a lens only, na? ఎలాంటి లెన్స్ ఎక్కడికి యూజ్ చేయాలంటే మనం ఈవెన్ హీ షుడ్ బి ఏబుల్ టు సీ ద ఆబ్జెక్ట్స్ అట్ 20 సెంటీమీటర్స్. 20 సెంటీమీటర్స్ లో ఉన్న వాటిని కూడా చూడగలిగేటట్టు చేయాలి. బట్ ఇనీషియల్లీ he is able to see with his own eye only the objects at 50 centimeters. 50 centimeters there ఉన్న ఆబ్జెక్ట్ కి 20 centimeters there ఆబ్జెక్ట్ పెట్టి దాని ఇమేజ్ ని 50 కి వచ్చేటట్టు చేసాం అనుకోండి, he is able to see that only, నా? అదే మనం చేయాలి ఇక్కడ. అంటే ఆబ్జెక్ట్ డిస్టెన్స్ ఎంత అవుతుంది ఇక్కడ? 20. ఒక లెన్స్ పెట్టాం అనుకోండి అమ్మ, ఇక్కడ 20లో ఒక ఆబ్జెక్ట్ పెడితే దాన్ని మనం 50లో ఇమేజ్ ఫామ్ అయింది అనుకోండి, అప్పుడు అతను చూడగలడు కదా, అతని క్యాపబిలిటీ 50 కదా. అంటే యూ కెన్ బి టేకెన్ యాజ్ ముందే ఉంటుంది కాబట్టి ఇట్ ఈస్ minus 20 centimeters. V, that is also in front of the lens only, minus 50 centimeters. Then focal length they are asking. For any lens, what is the formula? 1 by f equal to 1 by v minus 1 by u. So you can solve it now. 1 by minus 50 minus 1 by minus 20. This is nothing but 1 by 20 minus 1 by 50. And for this, LCM is 100. This is 5 minus 2. That is 3 by 100. Then focal length will be 100 by 3. But they're asking here power only, na? So power means 100 by focal length in diopters. If f is in centimeters, u and v are taken in centimeters, na? So whatever the answer you get, it is in centimeters only. So 1 by f badalu directly you can write 3 by 100. Then answer will be 3 diopters. Okay, very good, very good. Many of you gave the answers. That is 3 diopters. Very good, very good. Correct only. A nearsighted person cannot clearly see beyond 200 centimeters. అంటే అతను చూడగలిగేది 200 సెంటీమీటర్స్ వరకు మాత్రమే, అంతకంటే ఎక్కువ దూరంలో ఉంటే చూడలేడు అతను. ఓకే, ఇట్ ఈస్ గివెన్ హియర్. అండ్ ఫైండ్ ద పవర్ ఆఫ్ ద లెన్సెస్ నీడెడ్ టు సీ ఆబ్జెక్ట్స్ అట్ లార్జ్ డిస్టెన్స్. అంటే ఎంత దూరంలో ఉన్నా సరే అక్కడ వరకు మనకు కనిపించాలి. ఓకే, లార్జ్ డిస్టెన్స్ అంటే ఇన్ఫైనటే కదమ్మా. ఆబ్జెక్ట్ ఇన్ఫైనట్ దగ్గర పెడితే ఇమేజ్ మాత్రం ఎక్కడ రావాలి? 200 centimeters దగ్గర మాత్రమే రావాలి. Okay, so you can write here u equal to, some of you gave the answer, u equal to infinite only. What is given? Objects at large distance. And v equal to ఎక్కడ ఫామ్ అవుతుంది? అతను ఐ కంటే ముందు ఒక 200 centimeters దగ్గర ఫామ్ అవుతుంది. Okay, now power కనుక్కోవాలి. That means first you have to use the equation, that is 1 by f equal to 1 by v minus 1 by u. So this is equal to 1 by v means 1 by minus 200. 1 by u means infinite, na? 1 by infinite becomes 0. So finally here 1 by f equal to minus 1 by 200. But finally they are asking us to calculate power only, na? Power they're asking. Power means in centimeters if it is. The formula is 100 by F. So that is equal to 100 into F is given. 1 by F is given. Minus 1 by 200. ఇప్పుడు ఏమవుతుందమ్మా పవర్? దిస్ ఈస్ -1/2. దట్ ఈస్ -0.5 diopters. Now question number 17. A person wear glasses of power -2.5 diopter. The power of the lens he is using. The power of the lens he is using is -2.5 diopter. జాగ్రత్తగా వినండి, క్వశ్చన్ ఎక్స్ప్లెయిన్ చేస్తాను. Is the person far sighted or near sighted? I will explain here. -2.5 means which lens was used? Is the lens converging or diverging? You can give your answer through messages only. If I use -2.5 diopter, is the lens converging or diverging? This is a diverging lens only, na? Diverging lens ఎప్పుడు యూజ్ చేస్తాం మనం? ఫర్ ఎగ్జాంపుల్ ఇది మన కార్నియా అనుకోండి, ఓపెనింగ్. ఇది రెటినా అనుకోండి వెనకాల. సో ముందే ఇఫ్ ద ఇమేజ్ ఇస్ ఫార్మ్డ్ హియర్ ఓన్లీ, అప్పుడు ఏం చేయాలి మనం? ఇక్కడ కదా ఇమేజ్ ఫామ్ అవ్వాలి, రెటినా మీద కదా. అంటే దీన్ని కన్వర్జెన్స్ ముందే అయిపోయింది. దీన్ని కొంచెం కన్వర్జెన్స్ తగ్గించి డైవర్జెన్స్ పెంచి ఇక్కడ ఇమేజ్ ఫామ్ అయినట్టు చేయాలి మనం. అంటే ఏ లెన్స్ యూజ్ చేయాలమ్మా? We have to use here diverging lens for nearsightedness. So that since we are using here diverging lens, what is that? Nearsighted. Nearsightedness is the problem for him. And what is the far point of the person without the glasses? Without the glasses, ఎంతవరకు చూడగలడు మాక్సిమం అని అడుగుతు, ఫార్ పాయింట్ ఎంత అని అడుగుతున్నాడు వాడు. సో దానికి what is the U value? Infinite only. Object can be there, nearsightedness only, na? Object can be there at any distance, long distance. And V value you have to find out. Okay. ఎంత దగ్గరలో ఉండే వరకు అతను చూడగలడో మనం చెప్పాలి ఇప్పుడు. What is the formula here for lens? 1/f equal to 1/v minus 1/u. 1/f means how much? This is power only given, na? Power is nothing but 100 by f. 100 by f is -2.5. Then f is equal to -40. F equal to -40. Equal to 1/v minus 1/infinite. 1/infinite becomes 0 only, na? So what is the V value? -40 centimeters. That means if the object is at infinite, at long distances, he is able to see by his own, not by using any lens. He is able to see by his own only at -40 centimeters. దాన్ని రికవర్ చేసి కొంచెం 25 దగ్గర వేరే డిస్టెన్స్ చూడడం కోసం మనం ఏం యూజ్ చేయాలి ఇక్కడ? We have to use this lens. The question: a professor reads a greeting card received on his 50th birthday with 2.5 diopter glasses, keeping the card 25 centimeters away. Okay, by keeping that exactly at 25 centimeters, he can read properly by using some glasses of focal length or power given 2.5 diopters. That is the information for the first case. Next, 10 years later. Ante first I will write here before 10 years. First the information given before 10 years. 10 years later, let me consider that is present only. Present. He reads his farewell letter with the same glasses. That means he used the same glasses for 10 years. But he has to keep the letters 50 centimeters away. The object distance should be 50 centimeters avali. At present, object distance ఎంత పెట్టాలి వాడు చూడాలంటే 50 సెంటీమీటర్స్ దగ్గర పెట్టుకోవాలి. వాట్ పవర్ ఆఫ్ లెన్స్ షుడ్ హీ నౌ యూస్? అయితే ఇలా పెట్టేటప్పుడు ఫోకల్ లెంత్ ఆల్రెడీ వచ్చింది. అప్పుడు ఇప్పుడు ఒకే గ్లాస్ యూజ్ చేశాడమ్మా. ఫోకల్ లెంత్ ఎంత? ఇది 2.5 కదా. ఇది లెన్స్ ది 2.5. అంటే వాట్ ఈస్ ద ఫోకల్ లెంత్ దెన్? ఫోకల్ లెంత్ ఎంత అవుతుంది? 2.5 డయాప్టర్స్ పవర్ అయితే 100/2.5 నా హౌ మచ్ ఇట్ విల్ బి? 40 సెంటీమీటర్స్. ఫోకల్ లెంత్ విల్ బి 40 సెంటీమీటర్స్. కాకపోతే ఇక్కడ he uses the glass with power 2.5 diopter. But how much problem he is having? Minus 2.5 diopter power only, na? So that you can write here, focal length can be taken minus 40 centimeters. Minus 40. And of course, the same thing you can use, plus 40 you can use, no problem. So then you have to calculate V value. Now you write down 1 by F equal to 1 by V minus 1 by U. So that is 1 by 40 equal to 1 by V we don't know, minus 1 by U is minus 50. This will be plus 1 by 50. And finally 1 by V equal to 1 by 40. That way వెళ్ళిపోతే minus 1 by 50. 40 కి 50 కి LCM ఏమొస్తుందమ్మా? 200. This will be 5 minus 4. This is finally 1 by 200. And image distance is 200 centimeters. ఎక్కడ ఫామ్ అవుతుందట ఇమేజ్? ఇప్పుడు అతను 50 సెంటీమీటర్స్ దగ్గర పెట్టి చూస్తున్నాడు. అంటే ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది? 200 సెంటీమీటర్స్ దగ్గర ఫామ్ అవుతుంది. కానీ వాడు గ్లాస్ మార్చుకోవాలి కదా. ఇప్పుడు హీ హాస్ టు చేంజ్ హిస్ గ్లాస్. అంటే అప్పుడు ఏమవుతుందో చూద్దాం. ఎంత గ్లాస్ చేంజ్ చేయాలంటే విత్ న్యూ గ్లాసెస్ ఉండాలి మనకి. దానికి సంబంధించి ఏమవుతుంది? ఇప్పుడు 200 దగ్గర కనిపిస్తుంది వాడికి ఇప్పుడు. కానీ ఎక్కడ కనిపించాలి మళ్ళీ మనకి? 25 వచ్చి కనిపిస్తే ఇట్ విల్ బి ఈజీ ఫర్ హిమ్. సో దీన్ని మళ్ళీ అంటే దిస్ కెన్ బి టేకెన్ యాజ్ యూ. అంటే సారీ, -25 దగ్గర పెడితే ఇక్కడ కనిపించాలి కదా. అంటే u ఈక్వల్ టు -25. మనం 25 దగ్గర పెడితే చాలా అక్కడ కనిపించేయాలి. ఎక్కడ కనిపిస్తుంది అతనికి ఇప్పుడు? 200 దగ్గర కనిపిస్తుంది. uv. Now what is the new focal length? We have to use 1 by f equal to again 1 by v minus 1 by u. So equal to 1 by 200 minus 1 by -25 na? So that I will write here plus 25. This will be I think 9 by 200. 9 by 200. Finally the question is for power or focal length. Here they are asking what power of lens only, na? Then power will be 100 by f only, na? So that is 100 into 9 by 200. So finally power is equal to 100 into 9 by 200 is 9 by 2. That is 4.5 diopters. 4.5 diopters is the answer. See that question clearly. A professor initially at his 50th birthday, that means at the age of 50 years, what he is using? A 2.5 diopter glasses he is using, and he is able to see the book or paper, whatever it is, at 25 centimeters only. If he keeps at 25 centimeters, he is able to see that. But after 10 years, what happened? He has to keep the card or something at 50 centimeters only. Then only he can see the image somewhere. So that means what is the object distance? -50. And focal length of the lens he is using, that is 2.5 diopter. So focal length will be 40 centimeters. Then how, at what distance he really can see the image? 200 centimeters. అతను 50 సెంటీమీటర్స్ దగ్గర ఆబ్జెక్ట్ పెడితే అతనికి 200 సెంటీమీటర్స్ దగ్గర ఇమేజ్ కనిపిస్తుంది. ఇప్పుడు కొత్త గ్లాసులు ఎలా ఉండాలట? అతను చూడగలిగేది 200 సెంటీమీటర్స్ దగ్గర ఇమేజ్ ఫామ్ అయితే చూడగలడు. కానీ ఆబ్జెక్ట్ ఎక్కడ పెట్టాలి మనం? 25 centimeters ధర పెట్టాలి కదా. So with new glasses, the condition is U equal to minus 25 centimeters, V equal to 200 centimeters. దాన్ని సాల్వ్ చేస్తే you will get the answer that the power is 4.5 diopters. Question number 19. A normal eye has retina 2 centimeters behind the eye lens. అంటే లెన్స్ నుండి at 2 centimeters behind means image distance is 2 centimeters. Okay. What is the power of eye lens when eye is fully relaxed, most strained? So no instrument we are using here. Directly we are going to calculate here for relaxed, fully relaxed position and most strained position. Okay, Nama? Now, first I will go with fully relaxed position. Fully relaxed position ఎప్పుడు ఉంటుందమ్మా కంటికి? When U equal to, the first case is about fully relaxed. ఎప్పుడు రిలాక్స్డ్ గా చూడగలుగుతాం అంటే when U equal to infinite. When U equal to infinite. And already we know that focal length. What is the focal length? 2 centimeters behind it is given. Na? So focal length we don't know. What is the power of eye lens? That you have to find out. Focal length we don't know. But V ఎక్కడ ఫామ్ అవ్వాలి? 2 centimeters కదమ్మా. V equal to 2 centimeters. లెన్స్ కి రెండో వైపు కాబట్టి ప్లస్ ఏ పెట్టుకుంటాం. So what is the formula now? 1 by F equal to 1 by V minus 1 by U. That is 1 by V minus 1 by infinite. Of course, it is 0. So focal length will be 2. But you need to calculate power only. Na? Power is 100 by F only. Na? That is 100 into 1 by F is 1 by 2. So finally power is 50 diopter for the first position. And what is the second one? Most strained. చాలా దూరంగా ఉంటే రిలాక్స్డ్ గా చూడగలుగుతాం. అది మనం ఎంత దగ్గరగా వస్తే అంత స్ట్రెయిన్ ఫీల్ అవుతాం. ఓకే, అప్పుడు యూ ఎంతమ్మా? దగ్గరగా వచ్చిందంటే డిస్టెన్స్ ఎంత అని చెప్తాం? 25 centimeters. కాకపోతే లెన్స్ కి లెఫ్ట్ సైడ్ ఉంటుంది కాబట్టి ఇట్ ఈస్ minus 25 centimeters. Again, focal length we don't know. Power you have to calculate, of course. And V, final image distance should be on the retina. That is always 2 centimeters only. Now, by using the same formula, 1 by F equal to 1 by 2 minus 1 by U అంటే minus 25 కదమ్మా, ఇలా వేసేస్తాను. So this will be ఎంత అవుతుంది? 27 by 50. And what is the formula for power? 100 by F. 100 into 1 by F place లో వేసేస్తాను ఇలాగా. ఎంతమ్మా? 27 by 50. 52 are 227 are 54 diopters. So what are the answers here? 50 diopters and 54 diopters in both the cases. In fully relaxed position, that is 50 diopter. Power is 50 diopter for the eye. In most strained position, it will be 54 diopter. That means it is in between 50 and 54. The near point and the far point of child are 10 centimeters and 100 centimeters. If the retina is 2 centimeters behind the eye lens, what is the range of the power of eye lens? The similar question as previous question only, just in both the cases. First one, what is the first one? Nearest distance, when it is at 10 centimeters. Okay, now U equal to, of course, before the lens, it will be there, na? So it is minus 10 centimeters. And retina is 2 centimeters behind. That means image distance is always 2 centimeters. Then you can calculate 1 by F only, na? 1 by F equal to 1 by V minus 1 by U. So this will be 6 by 10. Okay. So 1 by f will be 6 by 10, which is equal to 3 by 5, I think. 3 by 5. Now, what is the formula for power? 100 by f only, na? That is 100 into 3 by 5, which is equal to 60 diopters. And for the second question, quickly I will solve that. U equal to at what distance? You can see that at minus 100 centimeters. Retina distance is always 2 centimeters, na? So image will be formed at retina, so that V equal to 2 centimeters. And again, in the same way, if you solve this, that is 1 by f equal to 1 by 2 plus 1 by 100, which is equal to 51 by 100. And power equal to 100 into 51 by 100, which is equal to 51 diopters. So his power is in between. His power of islands is in between 51 diopter and 60 diopters. A nearsighted person cannot see beyond 25 centimeters, assuming that the separation of glass from the eye is 1 centimeter. Find the power of lens needed to see distant objects. Distant objects means where should be the object placed? Object should be placed at infinite distance only. So U can be taken as infinite. And he can see the images at 25 centimeters, na? But his glass is at 1 centimeter distance from his eye. That means from here to here, the image will be formed at 24 centimeters only from the glass. From the glass, image is formed at 24 centimeters, not 25 centimeters. Glass nunchi manam count cheyali. So now you can calculate the power of lens only. So 1 by f equal to 1 by 24 minus, of course, 1 by infinite becomes 0. So 1 by f equal to 1 by 24. Then power, if you want, that is equal to 100 by 24. 100 by 24 will be nearly 4 point, nearly 1 something, 4.17 or 18. Nearly I will take 4.2 diopters. 4.2 diopters is the answer here. A person has near point at 100 centimeters. That means directly he can see the objects only at 100 centimeters. Below 100 centimeters, he cannot see the objects. What power of lens is needed to read at 20 centimeters? That means even the object is placed at 20 centimeters, image should be formed at 100 centimeters. Okay, then if he uses contact lens. First question is about contact lens. Contact lens in the sense, directly they are attached to our eye. There is no gap between spectacles and eye lens. రెండు కలిసే ఉండిపోతాయి. అప్పుడు ఏమవుతుందని అడుగుతున్నాడమ్మా. ఆబ్జెక్ట్ ఎక్కడ పెడతాం ఇప్పుడు? 20 centimeters there. So for the first case it is U equal to, కొంచెం ముందు పెడతాం కాబట్టి -20 centimeters. V equal to ఎక్కడ ఫామ్ అవ్వాలంటున్నాడు? 100 centimeters ముందున వాడు కనిపిస్తుంది. So that it is -100. So what is the formula for 1 by f then? 1 by -100 minus 1 by -20 కదమ్మా, ప్లస్ రాసేస్తాను ఇక్కడ. This will be, by taking LCM, you will get, I think, 4 by 100. 4 by 100, and you will get here power equal to 100 into 4 by 100. That is equal to 4 diopters. 4 diopters power lens we can use here. Okay. Now, what about the second one? When spectacles having glasses 2 centimeters separated from the eye, eye ki daniki 2 centimeters separation ఉందనుకోండి, అప్పుడు U ఎంత అవుతుందంటే 18 centimeters అవుతుంది. U will be equal to minus 18 centimeters. Okay. And V equal to, again, it has to form the image at minus 100 centimeters. Then by using the same formula, you will get 1 by F equal to 1 by V minus 1 by U. Okay. Okay. This will be plus 1 by 18. Now, you can solve this question and nearly you will get, I will solve that. 1 by 18 minus 1 by 100 only, na? This will be 82 by minus 18 plus 100. This will be 82 by 1800. You can just calculate that. So this will be 1 by F value, na? Then power will be 100 by F only, na? Then it will be 82 by 18. This is nearly equal to 18 4s are 72, na? 4.5 something. Nearly will get the answer 4.5 diopters.